Hello guys, I welcome you to the tutorial series on artificial intelligence, and today our topic is breadthfirst search. We have discussed blind search techniques in the last class. I'm giving the link in the description box below. Go through that class first because that will help you to understand about this search in much better way. Okay, so guys, if you have not already subscribed this channel, do subscribe it. And myself, Dr. Dibya Jyoti Bora. So let's begin. So breadthfirst search, as you have already got this one is also a blind search techniques. Okay, but you know that we have other blind search techniques like depth first search. Both generate and test and hill climbing are depth first search. Although they are easy to implement, but they spend a lot of time exploring unsuccessful paths. So of course, the first search is easy to implement, but sometimes it explores that path where actually means there is no possibility of the goal node, and as we have no idea about along which path that goal node will be there, because these are blind search techniques, so it spends a lot of time exploring those paths which actually result no goal. Okay, but breadthfirst search is the simplest alternate. In this, nodes at the same level of the trees are first examined before nodes in the next level are generated, just opposite to the depth first search. Here we search level wise. Okay, this search is easier implemented as a search curve. Okay, now if we speak about the main benefit of breadthfirst search procedure, then this is that it is guaranteed to find a solution if one exists, provided that there are a finite number of branches of the tree. And if a solution exists, then there must be a finite path of length n from a start state to the goal state. And breadthfirst search will explore all the parts of length I, okay, and then all the parts of length 2. So on until all the parts of the length n have been explored. And at the end, a solution of shortest path from start to goal state would have been found. Got it? So main point you need to note down that if there is a solution, breadthfirst search will give you the guarantee that it is of course going to find out that solution. The problem with this search are that it requires a large memory to store all the nodes at each level. And it involves a lot of work if path length n is large, and applying irrelevant rules to a state will cause more nodes to be explored. So the main problem we have in breadthfirst search technique is the large memory requirements. We are exploring all the levels, means we need to store those nodes at each level. So what happens if that path length n is large, then of course it will require a large memory. So main benefit, it will guarantee the solution, and problem that the large memory requirement. Okay, now algorithm of breadthfirst search. Step 1, place the starting node on the queue. So do remember that we are using the data structure queue with breadthfirst search technique. So queue, first in, first out. Okay. Now second, if the queue is empty, then return failure and stop. Means if there is no node in the queue, so we need to return failure and stop the search. Then step 3, if the first element on the queue is a goal node, then return success and stop otherwise. Means if the first node in the queue itself is a goal node, then of course our search is success, then we need to stop. Otherwise, step 4, remove and expand the first element from the queue and place all the children at the end of the queue in any order. So if there is another node in that queue which is not a goal node, then we'll expand this element, means this node, and children which will be generated by expanding this node, they will be placed at the end of the queue in any order. Then step 5, go back to step 1, means again place the starting node on the queue. So this will be completed, means this will be iterated until the queue becomes empty. So we'll return failure if there is no goal state in that tree itself, and if there is a goal node, of course we'll find that node and our search will be successful. This is the algorithm for breadth-first search. Got it? So if you look at this diagram, these are two graphs. We are conducting two different search techniques here. First one is depth-first search. I will discuss depth-first search in the next lecture. Now concentrate here. This is about breadth-first search. We begin from node A and we go to B, means this is level 1, this is level 2, level 3. So from A go to level 1, so expand all the nodes in the level 1, means A to B to C. Then come here at the level 2, expand all the nodes, that is D to E, E to F, F to Z. Then again go to the level 3, so expand all the nodes H, I, J, K. If any one of them is a goal, then we'll return success and we'll return the path. So A, B, C, D, E, F, Z, H, I, J, K. So we are concentrating on the breadth. So the name of this algorithm is breadth-first search, because we are concentrating on the breadth-first search technique. Got it? Now I am giving one more example. Consider this graph 1, 8, 5, 2, 6, 4, 3, 9, 10, 7. If we conduct breadth-first search here, the sequence of the path that will be returned here will be what? 1, 8, 5, 2, then 6, 4, 3, 9, then 10, 7. Is this clear? If any doubt still exists in your mind, then do ask me through a comment. I'll respond to those comments. Okay, guys? So we have discussed a very important algorithm, breadth-first search, in today's class. And you have seen that breadth-first search has the advantage of finding the solution if it really exists in that graph. And also one disadvantage of this algorithm is the large memory requirement. And we have gone through practically through two different examples. Okay, guys? So coming to the today's question, and today's question is, consider this graph. Now you need to conduct a breadth-first search for this graph and write the path found. So you need to comment the path found through breadth-first search technique on this graph. Okay, so we'll wait for your responses and we'll meet in the next class that will be on depth-first search. So guys, till then, take care. Bye bye.